Nature of the roots. We're just dealing with the b squared minus 4ac. That's it. If it's less than 0, my answer is 2 complex solutions. And if it's equal to 0, my answer is 1 double root. There's no distinction between those two. Less than 0, 2 complex solutions. Equal to 0, 1 double root. If you are greater than 0, you have 2 options. And perfect square. Then it's 2 rational solutions. Not a perfect square. Then it is 2 real solutions. And those are your answers. So my A equals 1, my B equals 6, and my C equals 12. 6 squared minus 4 times 1 times 12. Well, 36 minus 48 is negative 12. That's less than 0. 2 complex solutions. Usually when that C term is negative, we're going to be rational at the very least, if not real. Or we're going to be real at the very least, if not rational. And here you can take a GCF if you want. I'm not going to. I'm just going to use the numbers as written. So negative 6 is 36. It is a positive 36. That number is always positive. 4 times 2 times a negative 14 is negative 112. When you subtract the negative 112, the 2 negatives here make it positive. So we get 148, and that's greater than 0. It's 2 real solutions. Down here, negative 12 squared minus 4 times 9. That's 144 minus 144. 0 equals 0. That answer is 1 double root. And on these problems, I don't want you to find the answer. You don't get any bonus by finding the actual answer. I just want the nature of the solutions. Finally, 13 squared minus 4 times 2 times 15. That becomes 169 minus 120. That's 49, which is greater than 0. 49 is a perfect square. Basically means this can be factored. So that means we have 2 rational solutions. Okay, so if I don't reduce anything, my A is 8, my B is 32, and my C is 104, and I can do that. Negative 32 plus or minus 32 squared, I think, is 984, but I'm going to check it. Nope, 1024. That's why I'm glad I checked it. Minus, actually, let's just write the numbers in there first. 32 squared minus 4 times 8 times 104 all over 2 times 8. So we get negative 32 plus or minus 32 times 32, we have our 1024 minus 32 times 104, we get 3,328 all over 16. And now when I break this down, we get negative 32 plus or minus to negative 2,304. So I do need to break down the 2,304. Divide by 2. 1152. Divide by 2. 576. Divide by 2. 288. Divide by 2, we get 144. Divide by 2, we get 72. Divide by 2, we get 36. Divide by 2, we get 18. Divide by 2, we get 9. Pair of 3s on the bottom. So one pair of 3s, pair of 2s, pair of 2s, pair of 2s. And, oh, another pair. 2s right there. So let's go about it this way. One pair of 2s, 2 pair of 2s, 3 pair of 2s, 4 pair of 2s, and 1 pair of 3s. So 2 times 2 times 2 times 2 is 16. 16 times 3 is 48. So we get negative 32 plus or minus 48i over 16. So that's negative 2 plus or minus 3i is my answer. Now, my advice to you is not to do that problem. My advice to you is this. I'm going to divide everything by 8 here. And if I divide that entire problem by 8, I get this. And now I'm doing the quadratic formula from a much smaller number. Negative 4 plus or minus 4 squared minus 4 times 1 times 13. All over 2 times 1. And take a look at what happens. We get negative 2 plus or minus 16 minus 52 over 2. Negative 2 plus or minus negative 36 over 2. The square root of negative 36 is 6i. So my answer is negative 1 plus or minus 3i. If I'm not mistaken, oops, I'm sorry, it should be negative 2 plus or minus 3i. Let me show you the mistake. See I had negative 4 here? We don't magically change it to 2. Sorry about that. And we get negative 2 plus 3i. But you end up with the same exact answer. My advice, take the GCF out and then do the quadratic formula.